The haul road climbs out of the pit at a grade of 8%. A loaded truck, 360 tons of copper ore, pulls uphill. The engine labors, diesel smoke streams behind the cab. The driver's hands grip the steering wheel. 1 mile to go. The road is 28 meters wide. Safety berms stand 2.9 meters high on both sides. The road surface is crushed gravel, crowned 2% toward the center for drainage. Below the surface is a base layer of pit-run gravel. Below that is sand. Below that is the subgrade, the native material that has to support every pound of weight without deforming more than 4.3 millimeters. This is a haul road, not a highway, not a mine access road, a production haul road, designed, engineered, and maintained to move specific quantities of material at specific speeds across specific grades. Every dimension is calculated. Every curve is banked. Every grade is set to balance truck speed, fuel consumption, and safety. The truck crests the rim of the pit. The driver sees the dump zone 2 kilometers ahead, a waste pile growing larger every single day. The ore will be processed, the waste will be dumped, and the haul road will carry the next truck up, and the next, and the next, for decades, moving material, building infrastructure. The haul route is the circulatory system of an open pit mine. Without it, nothing moves. Without it, the mine doesn't operate. This is the engineering that nobody sees, the roads and dump zones that make mining possible. Before we go deeper, if this kind of mining engineering interests you, subscribe to the channel. Every video documents the infrastructure and the systems, haul roads, dump zones, the engineered solutions that make mining work. If that matters to you, the subscribe button tells us, and we want to hear from you. Did you work building or maintaining haul roads? Did a father or grandfather operate trucks on mine roads? Did you grow up near a mine and remember the roads? Tell us in the comments. The people who actually built and maintained these roads know details that don't appear in engineering documents. We want those stories. Now, the engineering. A haul road isn't built by accident. It's designed by mining engineers using precise calculations. The grade, the slope of the road, has to be steep enough that loaded trucks can climb it in reasonable time, but not so steep that brakes fail on the descent. The standard for most mines is 8 to 10% grade on loaded haul routes. On return routes, empty trucks heading back to the loading point, grades can be slightly steeper. The width is calculated from the size of the largest truck using the road. A 360-ton haul truck is approximately 8 meters wide. The minimum safe width for a two-way haul road is 3.5 times the vehicle width. That means 28 meters minimum. Some mines use 32 or 36 meters for high-traffic routes. Why? Because tire wear increases on narrower roads. Maintenance costs go up. Accidents increase. The road surface itself is engineered in layers. The top layer is crushed gravel, 1-inch crushed stone that locks together and resists tire wear. Below that is a base layer of pit-run gravel, usually 4 to 6 inches thick. Below that is sand, the subbase, and below everything is the subgrade, which is the native material. Whatever rock or soil naturally exists at that location. Each layer serves a purpose. The crushed gravel provides a smooth wearing surface. The pit-run gravel distributes loads across a wider area. The sand acts as a cushion. The subgrade has to be strong enough, tested using California bearing ratio analysis, to support the total load without excessive deformation. For a 360-ton truck, surface deflection must be less than 4.3 millimeters, 1/6 of an inch. That's the engineering tolerance. The design process starts with detailed geotechnical investigation. Engineers drill holes, extract core samples, test the soil and rock strength. They calculate the bearing capacity of the subgrade. They determine what combination of layer thicknesses will distribute truckloads safely. A poorly designed haul road fails. Ruts develop. Structural breakdown occurs. The road becomes a maintenance nightmare. Constant repair, constant downtime, constant cost. While the haul road carries material out of the pit, the dump zone receives it. This is where engineering meets geology meets economics. The dump zone isn't a random pile. It's a designed facility, sometimes the largest man-made structure at the entire mine site. At Bingham Canyon, Overburden waste rock is hauled miles from the pit. The trucks back up to the dump edge and dump their loads. Gravity does the rest. The material tumbles down the face, settling at the angle of repose, approximately 37 to 40 degrees. This angle is stable, steeper, and the pile would fail catastrophically. Flatter, and you waste valuable land. The dump zone has to be positioned where it won't flood back into the pit. It has to be stable. The weight of thousands of tons of stacked rock can cause slope failure if not engineered properly. It has to be accessible. Trucks need clear routes in and out, and increasingly it has to be designed for reclamation. When mining ends, the dump zone becomes part of the post-mining landscape. Some become wildlife habitat, some are reshaped for alternative land use. The material inside a dump zone matters. Engineers segregate waste rock by type. Strong, competent rock goes in the core. Weak or altered material goes on the outside where it can be monitored. Fine-grained material, clay, silt, is kept to a minimum because it absorbs water and reduces drainage. Poor drainage means higher pore pressure. Higher pore pressure means instability. The largest dump zones in the world are at coal strip mines. A single dump zone can contain hundreds of millions of tons of overburden. The dump grows outward and upward as mining progresses. At some operations, dump zones reach heights of 100 to 120 meters. That's the equivalent of a 40-story building made entirely of rock. Material flow through a mine, from loading point to haul road to dump zone, has to be balanced. If shovels load faster than trucks can haul, trucks queue and operators wait. If trucks arrive faster than the dump can accept material, haul roads back up. The entire operation becomes a choreography of timing and movement. Every minute counts in mining. The loading cycle, the haul time, the dump time, the return time. Added together, they equal productivity. Reduce cycle time by 10%, and you move 10% more material per shift with the same equipment. A typical load-haul-dump cycle in an open-pit mine works like this. The shovel loads a truck in 3 to 6 minutes, depending on bucket size and ore characteristics. The truck then travels to the dump zone, maybe 5 to 15 kilometers depending on pit depth and dump location. The haul time depends on grade, road condition, and truck speed. A loaded truck climbing an 8% grade at maximum rim pull moves at roughly 15 to 20 kilometers per hour. The dump itself takes 2 to 3 minutes. The truck then returns empty, faster now, without payload weight. The empty return might take half the time of the loaded haul. The cycle repeats. In a well-designed operation, this entire cycle, load, haul, dump, return, happens in 45 to 60 minutes. A single truck might complete 8 to 10 cycles per shift. A pit with 50 haul trucks moving material simultaneously means hundreds of cycles happening every hour. The haul road has to support this volume. Every truck that uses it adds wear. Every loaded descent stresses the brakes. Every uphill climb stresses the engine and transmission. The road surface deteriorates from this constant pounding. Ruts develop where trucks track the same line. Dust clouds rise from the abrasive surface. Water penetrates cracks and weakens the subbase layers. Road maintenance is constant. Graders reshape the surface daily. Water trucks suppress dust. Dozers rebuild sections that have failed. Compactors repack material that has loosened. At major mining operations, haul road maintenance might involve 10 to 15% of the total equipment fleet. Dozers, graders, water trucks, compactors, all dedicated to keeping the haul roads passable. The economics are precise. If haul road maintenance exceeds a certain threshold, the entire operation becomes unprofitable. If roads deteriorate faster than they're maintained, truck breakdowns increase. If truck breakdowns increase, production drops. If production drops, the entire mine loses money. A haul road is a dangerous place. Heavy trucks moving at speed, narrow margins for error, collisions between vehicles, rollovers on curves, brake failures on long downhill grades, tire blowouts at full load. These aren't theoretical risks, they happen. Mining has one of the highest accident rates of any industry. Safety berms are designed to prevent vehicles from leaving the road. For a 360-ton truck, the berm height is calculated at 2.9 meters, 3/4 the diameter of the truck's massive tires. A berm that's too low won't stop a truck. A berm that's too high creates a different hazard: trucks hitting the berm and rolling backward. Visibility on haul roads is limited. Dust clouds reduce sight distance to 50 meters or less. Curves have to be banked, super elevated, to reduce centrifugal force on trucks navigating them. Speed limits on curves are calculated based on the truck's center of gravity and tire characteristics. Too fast, and the truck tips. Too slow, and traffic backs up. Water sprinklers run continuously to suppress dust. Without dust control, visibility becomes zero. Operators can't see oncoming traffic, can't see obstacles, can't see the edge of the road. Accidents multiply. Some mines use calcium chloride or oil-based dust suppressants that stick longer than water. Emergency escape lanes are built into long downhill sections. If a truck's brakes fail, the driver has a place to steer, a sand or gravel pit designed to stop the truck safely. Without escape lanes, a runaway truck means catastrophic failure. The haul road is also an environmental challenge. Dust from the road surface infiltrates truck engines, air filters, hydraulic systems. The abrasive dust causes premature wear on machinery. The road itself erodes, requiring constant material replacement. In dry climates, fugitive dust from haul roads becomes a regulatory issue. Air quality violations, community complaints. The haul road and dump zone are invisible infrastructure. Nobody outside mining thinks about them, but they are some of the most precisely engineered systems in the world. A mine haul road has to carry loads of 360 tons repeatedly, thousands of times, without catastrophic failure. The engineering tolerances are measured in millimeters. The safety margins are built into every dimension. Modern haul roads are better engineered than roads built 50 years ago. Computers now model load distribution. Finite element analysis predicts how material will behave under stress. GPS guidance systems optimize truck routes. Real-time monitoring systems track road condition and predict maintenance needs before failure occurs. But the fundamental challenge remains the same. Material has to move from the loading point to the dump zone efficiently and safely. The haul route has to support the weight. The dump zone has to accept and retain millions of tons of overburden. The system has to work continuously, shift after shift, for decades. The haul roads at Bingham Canyon have been in operation since the 1950s. They've been rebuilt, regraded, and resurfaced countless times. But the basic engineering principles remain constant. Proper grade, adequate width, engineered layers, drainage design, regular maintenance. The roads still function because they were designed with respect for the forces they would encounter. When a mine closes, the haul roads are abandoned. Some are reclaimed, reshaped, and revegetated. Some are buried under dump material as mining expands. Some remain as scars in the landscape, evidence of decades of truck traffic, material movement, and industrial operation. But the material they moved is everywhere. The copper from mines served by haul roads is in electrical wiring, plumbing, industrial equipment still in use. The coal removed by drag lines and dumped at the end of haul roads powered electrical generators for 50 years. The ore they processed is in the infrastructure of American industry. The haul road represents engineering in service of extraction. A system designed to move the maximum amount of material in the minimum time at the lowest cost, while maintaining safety and operational reliability. It's not glamorous, it's not celebrated, but it's essential. If this kind of mining infrastructure interests you, subscribe to the channel. We document the systems, the equipment, the engineering that makes mining work. There are more mines, more roads, more operations still to explore. And if you have a connection to what you just watched, if a family member worked on mine haul roads, maintained them, operated trucks on them, or grew up near a mining operation, tell us in the comments. What mines? Which roads? What do you remember about the work? The people who built and maintained these infrastructure systems didn't write books about it, but you might remember. We want those memories. The haul roads and dump zones of American mining are part of our industrial history. Your stories help preserve that history.